I should start really close, right? Hey everybody, I'm Paul Shannon. I'm your host for tonight, and there is Alex. Alex Regan will be talking about synchronous. Hold on, let me get this right. Synchronous orchestration of asynchronous tasks. That's the longest title you could come up with, right?
Yeah, I didn't put that title on the slides.
But so we're going to start. We've already done our dinner. We're going to start with some TypeScript news, and then we're getting to Alex's talk, and then we're going to maybe do a little game at the end. It's brand new and something I'm trying out, so hopefully it'll work out. But Type This Way, we'll take some JavaScript, and people will try to put types to it, and maybe some people come up and show off their types, and people that come up can get a copy of Milestone Mayhem, which is a card game making fun of the development process. All right, so thanks to our sponsors DriveTime and SitePen. So DriveTime, this is the place you're at. Do you want to go ahead and say a few words?
Yeah.
Go ahead and stand up, come up here.
Oh my gosh, make me nervous. Okay, my name is
nice
Kayla. I'm the recruiting manager at DriveTime. I am new to the group here. So just want to take the time to utilize, we're happy to give you our space and food, but also want to kind of share a little bit while you guys are here, just some opportunities we have in the tech space. So a lot of people don't know DriveTime. We are a non-tech company. So we build all of our own apps in-house. We build all of our own software. So we, in this building, in our corporate office, we have about 200 IT folk that work here. So I think we're just trying to branch out in the market, get our name out there in the tech space. So just want to go over a couple open positions that we have. If any of you are interested or know anyone that would be interested in the job market or looking for new opportunity, feel free to have them go on our website, which is the careers page. It's all right there.
There it is.
So we have a dev lead available. We have a business systems analyst, senior database developer, senior BI developer, an assistant director IT telecom engineering. We have a software quality analyst, a junior cybersecurity engineer, database administrator, application developer level 3. So we have tons of evergreen roles. We have 3 of the dev leads open right now. We have a dev 3 that's opening. So we have tons of opportunity in the tech space. Just wanted to let you guys know that. I'll be coming on a monthly basis to talk to you about the open positions we have. I won't take too much of your time. I should have swag next time to make it worth your time to listen to me. But that's it. Just wanted to let you guys know we do have opportunities in the tech space. So if you know anyone, please feel free to mention DriveTime on that list of employers. But that is it. I'll let you get to your night and your evening. Enjoy the pizza. Enjoy your evening. I'm sorry the alarms were yelling at you. I'll try to get that fixed next time.
Awesome. Yeah, DriveTime's always been good to us. And so like if you're looking or know somebody looking, TypeScript and .NET are their keywords. So yeah, go ahead and send anybody their way or talk to Kayla about whatever you need.
Awesome. Thanks, guys. Have a good one.
Thank you.
Oh, applause. Yes. Thank you.
Okay, so and then I work for SitePen. We do consulting and stuff. More consulting than stuff, though. So in community updates, I am part of the TalkScript podcast at TalkScript FM. We just released 2 episodes recently. Episode 30, which is Idle Until Urgent, which kind of talks about optimizing your website and getting just-in-time type stuff loaded. And then episode 39, TC39 Pipe Dreams, where we talk about the TC39 process and how things get adopted into JavaScript. And we talked about a few of the up-and-coming proposals and the different stages and where they're at. And so both of them are fun. Like we really like getting out there with the podcast, and you can follow us at TalkScript on Twitter. So TypeScript news. If you haven't heard yet, TSLint and ESLint are merging. And so these are both linter tools that ESLint has taken on more and more of TypeScript linting and will now TSLint as the de facto linter for TypeScript. So the two teams are kind of working on merging together that technology and the linting rules and everything. So expect that going forward. If you're starting any new projects, use ESLint over TSLint because TSLint will be phased out. Tink embraces TypeScript. So Tink is the new NPM by NPM, which allows you to do things like run code, and it does stuff like I don't know, installs modules just in time, I guess, if you want to call it that. So it's essentially their new experimental like NPM. And so eventually Tink will replace NPM once it's been tested and proven stable. And one of the coolest things is it uses TS Node to run TypeScript natively, and you don't need to transpile or anything. It's all handled by TS Node. So we're really excited about that, and it's pretty cool. And then there's a link to an article about when to use never and unknown, the two smallest and largest types in TypeScript. And all of this has been posted in the Phoenix TypeScript Meetup, so the link is there in the comments. So you can go back here and click on those links and everything else. TypeScript 3.4 is coming out. Late March is when it's expected. There's actually a release plan if you care that deeply about it, but late March is probably good. It's going to include higher order function type inference. So if you have a function that gets functions, and those functions have parameters that are generic, those generic parameters can be inferenced from or inferred from your code, basically. There's going to be improved support for read-only arrays and tuples. So read-only now goes really deep into arrays and tuples. There's going to be a context, so you can take a value of something, for instance an object, and say as const, and that marks everything in the whole hierarchy of that object as read-only. You can also use it for let, and so TypeScript will treat it as a const even if it's a let in that case. So it's useful for marking things all as read-only and making sure that nobody touches things, and gives you the idea, or gives people the knowledge that those things aren't going to change. Even though JavaScript would allow you to do it, TypeScript gives you these protections. Partial type argument interface, it's an underscore. You can put an underscore where a generic is, and it'll infer for that underscore. So it used to be, if you had like 3 generics, you would have to start at the left side and go to the right side to fill out those generics. Now you can just say underscore and say, I'm going to skip this one, you figure it out TypeScript. And then global this, which is a TC39 stage 3 proposal, is being added to TypeScript in 3.4.
I think partial type argument got deferred.
What?
Yeah,
It's an underscore. How could it get deferred?
it got deferred until 3.5. There's some horrible thing about it. I was just reading because it pissed me off. Yeah, it got deferred.
All right.
Do you know who left the file behind for draft? Like, there's a big regression.
I think they're still having an issue over what symbols they're going to use, if they're going to use underscore. Like, it wasn't trivial, but it was, they couldn't agree on something, and I didn't dive into what it was. It was still an open discussion regarding something that, if I remember correctly.
All right. Well, I have to respect them. They're normally safe about these things, except for decorators and access modifiers, I guess. But aside from that, yeah, they at least have a plan going forward. So, all right, 3.5, we can wait, I guess. Yeah, and that's it. That's the end of the community update. So if you put your hands together, Alex is going to come up and tell you all about synchronous, asynchronous, synchronicity. What was it again?
running Linux, so peripherals and things like this is always fun. I'm Alex Regan. Been in the Valley my whole life and only started developing, 3-4 years ago. Used to be in print and audio engineering and all sorts of random different genres of career. But most recently I'm working for a startup that's doing a subscription-based social networking platform. So if that's intriguing or you know someone who needs work, talk to me because we definitely need a little bit of help. But that's all the plugging I'm going to do. So I'm going to talk a lot about async I/O today. So if you're more of a front-end JavaScript engineer, you're going to touch on this stuff, but this isn't going to be quite as powerful as if you're a back-end engineer because Node.js bread and butter is async I/O. So the idea here is, well, first of all, I/O is a little bit tricky. You have things that can fail. Asynchronous, always a little bit tricky when you enter, add time to the mix. So we want to find a way where we can actually create some error explicit handling for large pipelines. This we'll get into a little bit more, but for kind of a primer on the subject, JavaScript is single-threaded, which seems a little bit like a conundrum for how you could do anything asynchronous, but the short version is, I'll get used to that. So the short version is it doesn't do the async work itself. Instead, it kind of kicks off all this processing, and it's just like a manager, just like you go do that, you go do this. And it lets C++, the operating system, whoever's in charge, we don't really need to know. But chaining more processing onto the end of anything that's asynchronous gets a little tricky, and we need to work with callbacks. And callbacks kind of a funky paradigm, in my opinion. It feels very nonlinear because in a blocking I/O system, when you say something like fs to open file, the left-hand side, you catch the file handle. What happens in between, you waste time, but at least it's very easy to understand. And in JavaScript, we have this whole notion where, nope, I'm just going to keep doing work, and I'll come back to that later. So we have node callbacks, which is kind of the traditional plain version of how we do callback chaining on to the end of some asynchronous task. Now, I really like how callbacks have errors as values. I used to work in PHP where I used to work at, and you have, exceptions get thrown. That's kind of common to JavaScript, but I kind of remember this tool. So I used PHP Storm. It's a JetBrains product, and when they were able to power this sort of IntelliSense experience when you use doc blocks and you say @throws, and be like, oh, this function throws this kind of exception, and it was actually able to warn you, hey, you need to, you can turn it on or off, but you should probably try catch this. And I thought that was pretty awesome, really powerful. And then they took it a step further, like they kind of tend to do, and instead of just checking that function that you call, they extended that to kind of recursively check the functions that function called. And when that thing got turned on, the code base I was in lit up. And it was like a Christmas tree. Every function was not handling some error. And so the point is that when you have implicit errors, it's kind of like your eyes get open in a way to just wow, nothing is safe. This whole world is volatile. So in node callbacks, it's very different, right? You look in the function signature and it has an error as the first argument. You know this thing is something that can fail. So long but kind of important point there. Errors as values is powerful. Now TypeScript, if you're using the at types node, they do a really good job of typing the error type, and they give you the node error type. But they actually kind of lie to you, and they tell you that the error is that type and that the data is whatever type it's going to be. But in reality, we know that we actually have to check, is that error null or not, before we can access the data. And ideally, in my notion of an ideal type system, it wouldn't let me access the error if it wasn't there. It wouldn't let me access the data, if it was an error. So maybe that's something we could fix. But I do like the explicitness of the errors, like we talked about. chaining execution, like so this idea that I'm going to call building pipelines, right? Where you say, okay, do this thing, then do that thing, then do the other thing. It's the classic pyramid of doom. Everyone's seen it or experienced it. It's infamous. So promises are obviously a more modern way of handling this sort of thing. They really still are callbacks if you think about it. They just kind of have a little more state to them, and it's a better abstraction for the same idea. And it gives you this notion that you're in a promise chain, it feels a lot more linear. I like to think when you're in a promise chain where it's dot then, dot then, dot then, it feels like an alternate universe because you know that timeline is going to happen in the right sync or in order, but you know that the rest of your code can run at any given moment, and so it's just sort of an alternate universe that you have to reconcile at some point. So promises don't handle errors explicitly, right? You have catch syntax, which is basically a functional version of try catch. I like it a little better than try catch, but really kind of just leaves it back to implicit error throwing. The semantics are the same for catching, if you called some function on undefined as it is for an explicit promise reject. If you want to chain things on promises, it's super easy. Obviously, it opens up the async await doors. It's really just sugar for promises. But because errors got put in the background and put to the same semantics as any other error, we don't really have types for those values. I don't know if this is ever going to be something that TypeScript helps us out on or not, but technically it can't, because like I said, the same semantics for any kind of error are for the explicit promise rejections. So ideally, we could keep errors explicit. And if we have explicit errors, maybe errors as values, that would let us have typesafe errors, right? We wouldn't be guessing, with the duck typing assertions of, hey, is this an instance of error, or is this an instance of my special type? I don't know about you, but I found myself doing some not so clever tricks to make sure I had the right thing in a catch block. We would like to make accessing invalid values impossible. I like the saying, I think Kent C. Dodds is pretty, where I heard this the first time, make impossible states impossible, right? So we have I/O tasks, they can succeed, they can fail. We want to make sure that you can't access a success value in an error state and vice versa. So we also like the linear flow or pseudo flow that promises give us. So we don't want to lose that. We don't want to lose the chaining API. We want to be able to create these complex pipelines, like I was saying. So that chaining API is pretty nice, and it avoids our pyramid of doom. But what we're really after is something more, which is how could we handle errors? And I like to think of this that, when you start with your MVP product, you kind of ignore your error states. And then as you go, you're like, there are certain things that can happen in our system that we would actually like to recover from. And then there are certain things that happen that when they happen, we would like to explicitly handle them by maybe notifying a user of something in particular or logging something to some service, who knows. So if we could get a little bit more in depth on error recovery and conditional effects that are conditional to the branches of outcomes we have, success or failure, that would be ideal. So it can be a little confusing talking about tasks as an idea of some asynchronous operation, because what I've done is I've been exploring Rust and Go and some other languages. I sort of dabble with functional languages and never quite feel comfortable. So I know there are a lot of functional concepts. Just by show of hands, does anyone here, have they worked on Elm, ReasonML, Haskell, OCaml, something functional? Anybody? Okay, so you won't judge me.
I think it's all on our to-do list.
All on our yeah, exactly. So there's going to be, I may utter the word monad once, but I don't really understand either, so don't worry. So capital T task is going to be a type that we're gonna introduce, And it's the part of this library that I've created called safe types, because naming things is hard. And it's basically been inspired directly from Rust. So if you ever get into Rust and you come across there are two types, option and result. Those are where I started here. And then I was looking for something that let me sort of algebraically handle success failure cases. That's where task comes in. So, sorry for the little preamble, but tasks are basically promises, right? But they're lazy. So when you construct a promise, you pass in a function that knows how to do the work. Now I think that promises, I don't know, promises are fantastic, but the fact that they commence right away is a little problematic for certain things that you might want to do, to chain them together, to work with them in different ways. There's no way you can change that, so don't worry about that, but what if we could have a promise that didn't start right away? What kind of doors would that open up? So tasks don't run when they're created. They have a very similar constructor syntax that we'll look at next, but you have to explicitly run them. And the slide shows basically there are 4 ways to run them. The first 2 are important. The second 2 are more internal. So you can run them, you can try them, and basically these return promises. So, well, so you can fork them or exec them. We'll get into each method, but I like to think of tasks as like on a continuum of time. You have work that can be done, you have work that's in motion, and then you have work that exists as a concrete value, some outcome, right? So that kind of gives you task, promise, and then concrete values, just types. So tasks encapsulate their success types and their error types. And the fun part for me is the type inference on this when we go through it is really, really good. I do think that what you mentioned coming up in the next release might help, because I don't know if anyone else has encountered this. When you construct a promise, sometimes you have to kind of help TypeScript and sort of put in the generic parameter for what the promise is supposed to resolve with, because that whole notion of like, okay, I'm going to construct a thing, and then I'm going to pass in a call or a function, and that function's going to call the callback, and that's what I call that with. That's the generic. That's a little bit hard for TypeScript at the moment to infer, and we're going to see basically the same thing happens with task. So if you type them at construction, they work fantastic throughout the chaining API. So we can also build really complex chains because we have this API, like a complete set of what are called combinators. That's a Rust term, so I actually don't know what Rust meant by it, but I'm going to go over what I have taken it to mean. But suffice it to say that for now, combinators are basically ways that you can combine tasks to create a pipeline. So error propagation. This is sadly something that's near and dear to my heart. Error propagation strategies, when it's just lob this up and like unwind the stack, that's not my favorite idea. So if you have an explicit strategy for sending errors up, and you can actually transform them as they go up the stack or decorate them as they go up the stack, that would be ideal. And tasks are going to let us do that while I get bugged by a telemarketer. So the last point, it's exhaustively tested because, quite frankly, once I had an idea that was inspired by things that already exist, this is not a new idea necessarily. It was very easy to write, and it's really simple internally. So we're going to start with a little bit of type syntax because it's a TypeScript meetup. So does this look scary or confusing to anyone? It's okay to say yes. Cool. You can always ask questions. It's just me. So a task is generic over 2 outcomes. It's generic over its success outcome or its error outcome. And basically I like to think that it just encapsulates work. I like to think of, so typically you would hear the functional term that this is a lazy type, but I prefer to kind of think of it as latent. So it's almost like physics, right? Latent energy that can be turned into energy in motion, which would be something like a promise. So we basically have a value that can describe a unit of work, and specific, so it can be synchronous or asynchronous. It actually does not matter, but it best describes work that can fail. So it's generic over those types. Yes, we talked about that. So in the wild, because I've been writing this in production for a while now, I think over a year, but task itself has come more recently, maybe in the last 6 months. I see these two sort of definitions float around a lot. One is a type that is already prepackaged. So if you were to describe, hey, I would like to read a file, not just any file, I would like to read package.json, then that would be a task that resolves with a byte buffer or the node error. That error no exception thing, maybe you're familiar with it, it's basically just the Node.js error type for system errors. So that type definition, read some file, kind of encapsulates the whole operation. And it hasn't been run yet, because remember, it's lazy. So same thing, Redis key, and then you can, Redis protocol dictates that like when it's kind of doesn't have a value to return, you just get the OK string. So basically this will succeed with that OK string or a normal error. So then the other idea is a task factory, which is just a function that returns a task. And this is what I tend to write the most of. So in this case, you have like the driver for the read some file type, right? This thing says, hey, just give me the file name and I'll give you the task back. It's a little bit different way of thinking because again, remember that like this file reader function, right? When you call it and you get a value back, nothing's happened yet, right? It's kind of like RxJS if you've ever done RxJS. You do this whole thing, you get this whole chain, and then you're like, all right, this is pretty sweet, nothing's happening. You got to call subscribe on it, right? So like the task is very similar. You got to run it, but you can run it as many times as you want. Then you get the idea with the Redis set function. So to construct a task, actually let's skip ahead just to sort of look at how promises look in types, because we know them pretty well, I'd imagine, right? It's a type that when you call new on it, you pass in an executor function, and that returns you the instance of promise, which is generic over some value t. So the executor function, right, that gets two arguments. It gets its resolve and reject. And those are just callback functions. So if you want to resolve, you give it a value or you don't give it a value, but that becomes t. And then the rejection, it like saddens me a little bit, but it's like we just explicitly pass something to reject and we just discard that type information. So that's a little bit of a bummer, but we're gonna fix that. So here, task constructor is pretty similar, right? You pass in an executor function, except it knows both the success and the failure. And then subtly different, this is for API symmetry in the whole library, but it doesn't do a resolve and a reject function as separate arguments. They're buried in one object, and they're called OK and error. So this is what I'm saying. When you pass in this thing and it gets this resolver, and then you say resolve.ok, that is what TypeScript has a hard time of knowing, inferring what is that OK value. Or resolve.error, where you reject in a way, TypeScript has a hard time with those. So I didn't have a great name, but like encapsulated and factory, right? Like those are the two ideas here. So here we're going to construct a task that always succeeds and a task that always fails. So to construct a task, it looks somewhat similar, except now we are able, because the resolve and reject are in an object, we can destructure them out. You can choose to name it whatever you want and then dot into the OK or dot into the error, but for the sake of the slides, I'm going to destructure them. So we destructure the OK callback, which will resolve this task. So we're going to run a set timeout, wait a second, and we give it the OK callback, so it's not rocket science here necessarily. So when you look at the definition, we say this is a task that succeeds with nothing, right? It succeeds with void, and it never rejects. And does anyone know what never is? Is anyone familiar with never? Got a yes? Got some no's. Okay, so never he mentioned never and unknown, which are the smallest and the widest types. So never, I think the easiest way to describe this is sort of with an example, and I can write this out if this doesn't make sense, but imagine you go into an if block and you have some variable x, and you say if type of x is string. Inside that if block, the x would be inferred to be of type string, right? So if you go inside that if block and then you enter a new if block and you say if type of x equals number, that can never happen, right? Because we just inferred that it's a string. We guaranteed that we're inside that type or that if guard. That can never happen. That's an impossible state. So never basically describes that, and it will be able to tell you, hey, like this isn't going to happen. It's not really an error. Like I don't think it fails compilation, but it kind of tells you like you're just wasting your time here. This is dead code. So by typing this never, it would actually make it impossible for us to compile and invoke the error callback. And then, so conversely, right, the next one fails after 1 second. We destructure out the error callback to resolve a failure. And we say that the OK type, remember the first generic is OK and the second generic is error. So the OK never happens, but the error is just void. So I felt like showing off. There's fantastic IntelliSense all over. You'll see some random examples of this. This is enormous though. So this is more what you tend to see in the wild. So I don't know if you've been writing Node long enough that when promises first came out, I feel like I wrote this code all over the place. And then I thought, oh, you should write this as a dynamic thing, and that was a little hairy, and then TypeScript changed my mind about that kind of stuff. In any case, this is just a wrapping function for the fs read file method, right? And so we're basically taskifying. So you pass in a file as a string, give me the path, and we'll, this explicitly types it as an output of the function rather than doing that in line in the constructor. But it's that same signature that we've seen. It's the normal routine. So this, you can imagine doing this as a promise too, right? New promise, resolve reject, check the error, reject with the error, and then resolve with the data. So now we've like kind of gone over. Yeah, go ahead.
So in the last slide, how does task resolve ambiguous calls? Like if you call OK after error, or vice versa, or if you call error or OK multiple times, does it ignore it like promise does?
It does. It's identical to the promise behavior.
Okay.
Now, like, and just like promises, that's a little bit of like a gotcha because processing happens. It doesn't change what's resolved, right? But like stuff still happens afterwards.
Right.
So that's a potential gotcha, but it's no different than promise. There's a lot of symmetry with promise, intended here. So now we've made a task. Now we want to use a task, right? Like I said, they don't run right away. You have to explicitly run them. So this is potentially what you will use most at the other end, and it's task.run. So it's an instance method, right? So we can use we're going to use this function here, right? So we have our read file function, and we're going to say go read package.json. And what we get out the other end is a task that encapsulates that work. And it knows how it will succeed or fail. And so we can run that task, and what you get back is a promise. So like I said, tasks are kind of like work before, and then once they're in motion, they kind of get converted to promises. So at the other end, you get this result. So task.run never fails. In order to not lose the error information, we can't throw. So what you end up doing is you sort of wrap up success and failure in a little box. It's the Schrodinger's cat thing. So the result type is either, and this is the one time I'll say it, this is basically the either monad. If you ever know it, hear it, and I think I've reversed order, so that's where if you were really deep into Haskell or something, you would probably like crucify me for doing it in the wrong way.
It's all good.
So basically result can be in one of those two states. And like I said, we want to make impossible states impossible. So you actually have to match on it. there's a whole API of combinators for result as well, but that's not what we're talking about. So in short, to match it, we pass in an object that describes its two possible states, which are analogously OK and error. And we pass in functions, and those functions get whatever value was typed in the task. And because they're functions, that allows us to sort of like not have us do something with a value that doesn't exist before it happens. We can talk about that if that makes sense, but what we would not be able to do with promise is what we're doing right now in the example, which is getting full IntelliSense on the error, right? Like this knows exactly what the node error has in it, and it's able to provide, completions for us. I guess one other point is that technically the match method, which is like pseudo pattern matching, requires you to return the same type from both of those cases, OK and error. So in this case, they both return nothing, so that's fine. So the other way is when you're just too tired to deal with it. This is the MVP method. This is try. So basically, we have the same setup. We want to read package.json, and this time we don't really want to. This is like the YOLO slide, right? So just run it, and if that error value ends up being the outcome, throw that, right? So that's basically just turn me into a boring, like exactly the same promise. And you can see that it doesn't get confused. It knows now we actually have our buffer, and we threw away the information about our error. Because technically, if something else went wrong, that would be conflated with the error from node. So now, these next two methods are, like I said, a little bit more about internals. But maybe if you're curious, the light bulbs will kind of go off. So fork, you pass in the same kind of object like you think of when you match on the result. So you describe what you want to do in the case of success and in the case of failure. And this is actually what gets passed to your executor function, this object right here. And so this is slightly different. So what comes out of the other end of fork is a promise, and it packages up both outcomes in the result. So technically, run is just like some boilerplate reduced to you, so you don't have to write this fork function, and always just return the value that it gives you. So any questions?
So you could await that fork.
Exactly. Yeah, so what I tend to do, in the code that I'm writing, if I need the value and I need to figure out what it is, I tend to use run, and I wait on that. But what I like to do in my route handlers in Express, for example, is I just run this fork function, and then I respond in success and error cases. And because there's some wrapping function, I have to make sure that the function waits until everything is done. So there's some extra stuff. So I just await this so that the function doesn't return too early. So that is kind of handy. The exec function, we're also illustrating my in-code documentation. So the exec function is kind of weird in and of itself. It just runs your task, and it throws everything away. It doesn't even allocate a promise. Like, it just runs it. And this is once you've like prepackaged up all this functionality, and you don't care about the values anymore. You probably already handled them, or you don't need to handle them. And so you just want to run it. And there is a reason for that. Some side effect processing, basically. So, yeah, so we're going to move into the combinators, and then we're going to look at a code example. So just double checking any questions, want a little more info, anything? Cool. So like I said, I don't know what Rust meant when they talked about their combinator API for options and results. But what I've come to determine is that what makes task special is that because it's generic over 2 types and no more, it's a binary set. And binary sets, it's not one thing, it's another, right?
It's some oil.
Yeah. So the most common binary set would be a Boolean. And we know how to work with Booleans, right? We have and or. They're like, that's the API. That's it. Booleans are, because they're a finite set, because there's only 2 of them, there's only so many things that we can do with them. And so we can kind of apply the same ideas to tasks. So if you have two booleans to evaluate, and you use an and, you know, you can kind of do the boolean table thing, right? If the first one's true, then we proceed to evaluate the second one. Regardless of whether the second one succeeds or fails, that's what's returned. So the same idea is with tasks, right? If you have a task that's a success, then you want to chain another one together, and you chain it with and. Well, you evaluate the first one, and if it is success, then you evaluate the second one. And then you return whatever happened from that. So, and then is just, oh, sorry, I saw it. So, and then just sort of changes that up because these aren't just booleans, right? Sometimes we want to take the success value and chain that into the next task, right? So it's kind of like, and says, here's two encapsulated tasks, evaluate them, and then says, here's one task that's already prepackaged, and then I'm gonna do sort of the task factory thing and give you some new task to run with the value of the previous one. So then or says, okay, well, it's more of a recovery type of thing, right? If the first Boolean is true, we don't do the second thing, right? We don't evaluate the next one. It short circuits. So it allows for a more of a recovery type of functionality. So if a task fails, you would evaluate the next task. And then or else is just symmetry here, right? If the first one failed, pipe the failure to me, and then I'll return you another task based on that failure. So those are what I would call branching combinators, right? You're saying, I have a thing that can succeed or fail, and then I want to chain it together with another thing that can branch into success or failure. Sometimes you just want to say, like, I just want to like take the file buffer and UTF-8 encode that so I get a string. That would be a transform. And you could do the same thing with an error. So there are two methods for that, map and map error. And in the same Boolean analogy, when you think of map and task, you have a true that's generic over a value, and so you just sort of map a true of A to some new value, true of B. And so that would be task of OK1 and into a task of OK2. We'll take a look at that in the example. And then, like I said, same thing for map error. So it's kind of just the core pieces of like applying Boolean logic and some transformations. And this actually opens up a lot of explicit opportunities for us to chain things together and explicitly handle recovery strategies. And the most interesting thing to me about the laziness of tasks is we deal with asynchronicity on the construction, and we deal with asynchronicity when we run a task. But this whole middle ground where we're passing tasks around and we're combining them and chaining them, it's entirely synchronous. Because they're lazy, they're not running, so doing a task and another task, doing a task or some other task, right? Like read this file, or if that fails, read this other file. Read this file, then go write that file, right? That kind of stuff all happens synchronously.
So for your and then, you're talking about feeding when it says feed the previous true into the next bool, that's the result of the previous task into the next task?
So with an and then, you're basically correct, but what you get fed in is not the result in the sense of the other result type, which is either success or failure, it's the success. So,
oh, sure.
So like in the read file example, right, let's say you just read it into a string, it will pipe the string into your next thing that returns a task that can branch again. So we're gonna go into a code example, but I guess this is probably poorly placed. There's some links. I'll put them in the Meetup on the web, and now we'll go into some code. So I kind of was just thinking, like, what's the simplest way to do this that shows a little bit off but isn't like too hard to kind of grok? And I just sort of went down the rabbit hole of like, what about ETL? Extract, transform, and load, right? You have maybe microservices and you want to pull from their different databases, prepackage this stuff up into some data structure that's more queryable for analytics, pipe it into your analytics database. And we're obviously not going to do the databases, so a good analog is a file system, right? It's still asynchronous, it's still I/O versus like an in-memory storage. So we're going to do this with files, right? Read a file, transform the data, write a file. But that's too easy, so we need to mess with it a little bit. So I was thinking of taking the input from a config, and the way ESLint or something like that says, hey, we accept like these 4 different file types, right? .eslnrc or .json or .yaml or whatever. That, if you think about actually going out and finding someone's ESLint, that's probably a little bit of a pain, right? Like how many different files do you have to try before you actually get to it? So what we're going to do is we're going to mimic that, and we're going to say, okay, our config for our input and outputs could exist in like 3 different places. Let's go check it, retry it, and do that. And then basically at the other end, the directory we're going to write to may or may not exist, so we may have to implicitly write all of the parent directories and build the path, basically make dir-p. So the common code that's going to be shared. So I tried to implement this in callbacks, promises, and tasks. So you can see and judge for yourself a little bit. And what ended up happening is callbacks sucked so bad that I kind of stopped 3/4 of the way. And then I wanted to go to the tasks because I'm so used to writing them lately, and it was like, oh, I need to get away from the callbacks. So I wrote the tasks, and it went beautiful, and I was really impressed. And then I wrote the promises after I had just looked at the tasks, and I was like, wow, you can kind of do this with promises, but there are some subtle gotchas in there that's where tasks are different. But I also would not have written the promise code the way I wrote it if I hadn't written tasks. So you're gonna get the results here. So just real quick, if anyone can't see, let me know, but hopefully this is enormous. So we have our config interface. It's just one input file, and I pulled from some open CSV data, and it turned out to be like crimes or something, so that was a little maybe morbid, but oops. So you have our input file, and then we have different output files for each strategy, we'll call it, right? The callback strategy, promise, and task. This is nested in a source directory, so we go up for home because things are moving around. And I don't know, here's our different config files, right? We're gonna try and resolve conf.json, app.config.json, and config.json, right? This is just the kind of silly things that you're like, I can't remember what this guy wants as their config file, so we'll check them all. You could imagine parse config to actually be a thing that succeeds or fails, but in this case, it's just gonna turn it into our well-typed structure. Encoding wasn't really that task-oriented. So what gets interesting is what is a thing that can branch and succeed or fail, and what is a thing that's just transformational logic. And I feel like tasks kind of highlight that. And so in this case, encoding is just simple. It's synchronous, it's always succeeding, and it basically just JSON encodes something and then encodes that again into base64. And because I'm a sucker for punishment, I wrote a CSV line parser. Why not? It worked. All right, so we'll start with callbacks, and then I'll take you on my journey to tasks next, and then looking at how I decided to inform that into writing promise code. So, I mean, right away, I see the pyramid of doom emerging. It's not terrible. I tried my hardest to give this a really good go, but we have our resolve conf function, right? So that makes sense, right? We want to try that whole list of file names. It takes a callback, and we're not doing error first callbacks because that would have been horrendous. And so we're just gonna, this is not as easy to do on this table. So then we're gonna read that file and then parse that into the CSV, which I assume should also do the, oh, sorry. Here's the base64 encoding, kind of hidden. And then ultimately it writes the file. This is where I gave up and did not want to do make dir-p. So the one that really sucks here is looking at how resolving the config file was implemented. Now, I'm sure someone can do this cleaner in callbacks, but I do consider myself a pretty competent JavaScript engineer, and it wasn't very apparent to me. And so that would at least tell me that this is not going to be easy for most people. So there's a resolve conf function here, takes all the configs and then the callback. And then there's going to be some counter, oh goody, internal state to mess with. There's an internal retry function with an internal callback. And if we go down a little bit, here we retry that, and then we determine if we're just going to panic or we're actually going to resolve and pass this up. So the way this recursive sort of thing, so I think that generally callbacks lead you to recursive patterns. So it does this clever thing that I would try to avoid, but I just didn't feel like figuring it out, where we grab the config file and increment the counter so that we can go and try and find this file and then turn it into our object structure, and then check the error and then make sure that, like, have we exhausted all of our possible file names? If we have, then we're really done and it's totally wrong, it's borked. Otherwise we can keep retrying and maybe we'll get it right the next time. And you'll notice I got mad and I called out the lies. So I tried to mimic the way at types node functions, right? Because I'm trying to do the node callback pattern. And like I mentioned before, it always types the error and the data as concrete values. It doesn't type them as some sort of a function overload that says error is null and data is t, or error is node error and data is void or null. So to do that, you end up lying to TypeScript. And I don't like that. Because it makes me wonder, like, what am I doing? Am I really doing this right? I just lied to you, you can't help me. So that ends up resolving this little bit. Read and parse is not that crazy. You call read file, and then we pass the parsed contents into the done function, and then we do the inline encoding and write the file on the output. Ideally, we would do the recursive checking for the directories, but that's what makedirp, the Substack package, does for us, which is how I implemented that in tasks by figuring out how he did it. So, not my favorite code. As far as code length goes, it shorted us out on some extra pieces. It is the shortest one here because we don't have to wrap a whole bunch of node APIs because we're using callbacks. So tasks are interesting. The app itself that packages up all this processing, we don't have to wrap in a function because tasks are lazy. So this is kind of like, you know, you might see in RX or something where you expect everything in the world and with a $. That's kind of the idea. This is sort of our, instead of a stream, if you like the RX way of thinking, this is a pipeline, right? So it's not something that's going to emit over time. It's something that can be rerun many times. So we have a resolve, and we need the resolution. So in other words, if we resolve our config file, we need the config file to do the next step. So we need a success, so when we change successes, we do ands. And when we need the previous value, we do thens, so and then. So we get the config, and it knows what we've got here. You also notice there's no more type information going on here. They're all at the function level. I was trying to stay true to what I was preaching, which is that, like, when you construct these, you should type them, and the rest of this should just work. So here it kind of knows, like, hey, this is going to resolve with our config file, or it's going to reject, if you will, with our node error. We get the config, we are going to read that file, we'll parse it to CSV, and then encode it to base64, and that resolves it, which, if we do all those steps, then base64 would come out a string, so that's what we get out the other end. You get your base64, and then you write to that output file. So we have to run our program, so we just call app.run. That returns a promise that has that, like, Schrodinger's cat box that wraps up our two outcomes. So in the then callback, we just match on it and we'll log success or failure. But the point here is kind of that, like, it's explicit now where our failure happens, and we can do more here, which we'll do in our resolve config. So this retry logic for the different file names kind of got smaller. Now, what we're doing is we're basically getting a task handle, if you will, right here. And this is the same read file function that we've kind of gone through once before. So in this case, it's sort of pre-set up to just resolve with strings. So we get the first task with the first file name. And you could do more checking and things like that, but that's not really pertinent. So then, in order to do recovery for each subsequent task, or sorry, each subsequent config file, we'll go ahead and slice the array and just get everything after the first one that we've already kind of declared. This is what we'd like to read first. And we'll do our recovery pattern, which is an OR, right? So like Booleans, if the first thing is false, then let's go and evaluate the next thing. So we can just pass in read file of whatever file name we're iterating over, and then we can save this as on the same variable, but a new handle to a task. So this is something I don't personally see a lot of promise code doing, unless it's sort of internal to some utility helpers, but you can do this with promises. But basically, each task, so when you say, I have a task that is a read file task, and then I have another task that's a read file task. And I say, the first task, if it fails, read that one or read this one. What you get back is another read file task. So it's the same exact shape, and it's already encapsulated both operations. So you will read one or both of those. And as you go through, you end up with sort of like a linked list hiding in the background, in a way, of all these different tasks. And like I was kind of mentioning, now transformation logic versus branching logic sort of shows up clearly. We know that we've dealt with the read file being I/O, and now we just like to transform successful I/O, right, and just turn it into config. And so once we do that, we go into the read and parse and do all this goodness. So here we have our read file, because now we're going to get a new input file to finally look for this thing, and then we map that. So we're going to transform the file contents by parsing it into CSV. And so read file, again, it knows it's going to be a task that succeeds as a string, fails with a node error. And map says, oh, okay, well, sorry, there's a lot of generics. These do get a little bit big. But basically, we're going to turn that into a two-dimensional string array, right, which would be a CSV file is a bunch of lines, so an array, where each line is a bunch of fields, which is an array. So once we've done that, we have our two-dimensional string array, and we're just going to turn that into basic-C4, so back into a string. We move around, and then we write our output file, and this is where it gets fun with the makedir p. So when we write our output file, we're going to get our path name. So this is basically, this is the output file with all of its dependent parent paths. And then we'll get the directory, and we're going to, this is kind of interesting to me. We can like pre-package up the right contents. So like when we're going to write the file, we can pre-package that little thing and reuse it in different conditions. But first we'll check if this directory exists. And if it doesn't exist, then we're going to go ahead and write if it does exist, we write the contents because we don't need to do any extra work. But if it does not, then we'll recursively make its parents. And if that succeeds, we'll write its contents. So going through this, you typically implement exists by just statting a file. And if it fails, well, it doesn't exist. And if it does succeed, then it exists. So this is just like the typical, just like promises, wrapping up the FS API. This one resolves with stats. And then what we do to turn stats into a does this thing exist or not is we stat the file. And then on a success case, we just resolve with a true, basically. But we're going to combine this in tasks, so we're just going to basically need to package up a task of true that is successful. And then we need to recover, because if stat fails, we know the file does not exist. And so we'll just wrap up a task of false. Make dir is pretty simple, and it doesn't really have anything to resolve with, so it's void. But make dir p is really not a lot of code. So if you go in the repo here, you can kind of like take a closer look at how it's able to sort of recursively work its way through a nested path, where you have ABC as a path, and the first go around, we want to make ABC. So we try making, we create this rerunnable task to make that path, and then what we're going to do is we'll try it the first time, and we'll see if it fails, right? And what we're looking for is basically a no entry error, right? Like this file doesn't exist. And the only reason this special clause is here is because I actually looked at the make derp package to see like how is that implemented, and I was like, oh wow, this can actually fail in an interesting way. But this is kind of a nice aspect of tasks, right? Because if we need to explicitly handle some failures and not others, again, it's really nice to know what you're dealing with here and see that like, okay, well I could use the error now, or I could use the code, whatever. It's gonna, TypeScript is still here to help me out as I deal with explicit failures. And ultimately, maybe we can talk more about this, but it lets you kind of open up your mind to your application code, having not just custom data structures for your data types and your operations, but it also lets you have custom data structures for your failure cases to say take something like payment processing and say, well, we really want specific handling for something like we don't accept that kind of credit card, your number must be wrong, or you don't seem to have sufficient funds, right? We can construct a data type to sort of package up all those cases and then handle them explicitly. But basically, this, if it's not an enowent, it's totally borked, your file system is broken. Or maybe you just don't have permissions. But you would just slice off the end of your nested path and then work your way back through the function. And when you recursively call it with the sliced off path, you just want to say, hey, once it's all done, make that original path, because you've apparently made my parents. So again, it's a surprisingly, at least to me, surprisingly small amount of code, and it's unfortunately kind of clever code, because that's what recursive code always ends up being. But if you want to check this out a little bit more in depth, you can kind of walk through it and step through it in your mind, and there's a little bit of some hints to help you out. So that's more or less what's going on here. And then in promises, we end up kind of being able to do the same thing we did in tasks, but some weird, like seemingly subtle changes happen. So we can resolve our config, and just everything's going to be .thens, right? And so yeah, sure, we get the nice, or maybe not so nice anymore with all the flat mapping type potentials. But we work our way through this chain, and I don't really think I need to go over it because it's pretty much the same chain. But let's look at some of the interesting bits, right? Like we kind of had a little clever bit of code to resolve the different file types. So we can actually implement a very similar trick in promises, right? We can get the handle to the first promise of reading that file, which it should be noted is already starting now if this function has been invoked. And then we can successively check the other files and say, if anything happens, catch that and return a new promise to read the next file. So this doesn't happen until something fails. So it's not like you're going to do extra work and spam your file system trying all of these things at once. So this would be the way to do that. It doesn't spam your file system. But this catch could actually come up for other reasons, which in development at least can be a little bit problematic, because we make mistakes in development, and tasks make explicit the distinction with, I wrote a syntax error and this thing failed in a way that I expected. But that is not going to happen here. And so everything also, the branching logic versus the transformational logic, they're all just .thens. I mean, arguably that's possibly nicer because it's just one method. So maybe that's a plus, maybe not. You notice that's kind of the way things work with the read and parse CSV to base64. You're doing transformational logic with .thens. And then writing the output file, we notice that we have to kind of wrap stuff up in functions to make them lazy, so that we can do the same idea of saying, well, we need to use this idea of writing the contents of this file in two cases. So we invoke it here versus we pass it as some .then callback over there. These sort of things are kind of subtle. You know, invoking these functions, wrapping them in functions, and then alternately passing them as handles. I definitely see these sort of things get beginners a lot. And ultimately, I think that when you get in more complex strategies of recovery, this sort of small amount of changes and extra wrapping and whatnot can actually get a little bit more complex. But if you notice the make_p, we're actually able to kind of do the same trick, make the nested path, catch it, check the error. Of course, this time, I mean, we're on our own here. Not my favorite thing, but if your library has good documentation, maybe that's not too bad. But that never happens either. Then we just, you know, handle the recursive case and make sure we remake the parent directory. So it's interesting to me that you can make promises do the same logic, but personally, I don't think I would have quite written this style of promise code until I had sort of opened the door with these more explicit strategies to recover from errors versus, you know, just catch things and not really know what I'm dealing with. So, so now you've kind of seen, like, this is how the Combinator API works. This is how it makes distinctions with chaining successes and chaining recovery logic. One interesting thing to note is that because the, let's see if I can find my documentation page. Aha. So this is just TypeDoc. So this is only there for API reference. It's not proper documentation. But if we look at the task, I'm not connected to the internet. We won't look at the task, but we have at our disposal a couple helpers for parallel cases, like task.all, which entirely mimics promise.all. So the first task that rejects, we make the whole array of tasks reject. So basically, if everything works, you would get an array of success values, but if something fails, you get a single failure. But one of the things it opens up that's slightly interesting is this idea of what I call task.collect, which says, I have a whole bunch of things that I want to run, and I need to know that every one of them runs. And then I'd like to know who succeeded and who failed. So task.collect always resolves with a success, and it will collect up your successes and errors into arrays, and basically give you a tuple as the success value, right? Successes, errors. That's pretty nice to be able to have. That's kind of a different thing to do. Because tasks so well encapsulate their success and failure logic, we also get retry functionality in the library. And if you want to do retrying with exponential backoff, there's a function in there. And you can just say, hey, here's this thing I want to do. I want to call this API. And you're like, sometimes, you know, it might be down, it might be overloaded. So you can generally, when I try implementing retry logic, I go, all right, we'll do the retry bit. And then the first thing you watch is you spam that API because you didn't implement backoff, which is this idea that, like, when something fails, please wait a little bit. And if that fails again, maybe we should wait a little longer, right? Like reconnecting to the internet. If you try to reconnect to your internet 100 times, you'd be amazed. Node can do that in less than a second. And obviously your internet's not gonna magically come up in that time. So it's nice to have little tools like that. And because, like I said, tasks just sort of let me at the library level know how to determine if your thing worked or didn't work, you know, you can let me handle the logic of retrying it and delaying it, and you get some parameters to drive it with, like, what would you like to have your incremental steps be in terms of backing off in time, and the cap for the maximum amount of time, that sort of thing. And then the last two things are really, you can do interesting side effects with this. So you could write this, you know, credit card processing pipeline, right? And it makes a lot of success failure calls, and then somebody says, we really need you to connect that to a messaging service, like Slack or something, I don't know, and just let us know when new orders come in. And you're like, well, that sounds great, but you're telling me once the order's succeeded, you want me to do something that can fail just so you get a notification. Like, I don't think I really want to do that and jeopardize, this person looking at the other end of the web page and saying, oh, it didn't work. Oh wait, it did work. Because then a whole mess of things can happen. Like they retry again and now their card won't work because that transaction's already gone through. But you can do side effects to say, okay, well, if this did work, do this effect, which would be a task, or you can do a task factory. And that lets you sort of say, okay, I wrapped up the Slack call in a thing that if it fails, who cares, right? Like, too bad. And so you can say, all right, well, I can insert this into the chain, right? And if you think of like the RxJS where we're streaming values and they're changing and they're moving and then they eventually become a result, the effects actually don't affect the chain. It's like a T, right? So you sort of pull out and say like, okay, from here, we'll run this thing and you can tap into the stream, if you will, the pipeline where that piece of data is, and then run your side effect. But you can also do that when things are in a failure state. So that might let you call out to, I don't know, Sentry or something as a service and say, hey, I'd like to log this particular error, get some more telemetry on that kind of thing. I use this a lot personally, handling activity logging in the social networking app, where essentially if you want to check your suspicious account activity and go to your history, every action that you do on the site that creates a log entry, well, that shouldn't really jeopardize your interaction with the API. So we were kind of writing log records as a side effect, and I think that's actually where I was inspired to extend this whole idea. But yeah, so successes, failures, we get a really explicit way to handle complex pipelines for async IO, and that's the idea. Some questions? I'm curious if there's any use cases where you're like, that would make doing X easier. Because I know I talked to some people, so I use this in production and it works great, but it does drive on some functional concepts that make it hard to explain to people in Slack. So this is one of the main reasons I would love to do these talks and get better at explaining it and maybe getting the value proposition over. So if there's any feedback, I'd love to hear.
So what would you say is the best thing of using tasks over promises? I know you talked about error typing, which is nice, but it looks like there's a lot of explicit pathing that happens in tasks versus like a promise you just resolve or reject, but tasks seem to have like known pipelines. Is that kind of like what the real benefit is as you see it, or is it more to it than that?
Well, I think it is about kind of at that low level of that's the idea. Like you have plumbing now for handling both cases, and you also get this sort of synchronous API in front of chaining them together. But one thing that I look at is like as you go through say like a route handler in an HTTP server, you get at the lowest level, right? And you say, okay, there was this database error, and that error has like no information about its context. Its context is like something failed, like a key constraint. Does that help anyone? Not really. So when you have errors as values, what you get to do is step up one context for the caller and say, oh, well, I was trying to create a user with an email, and then you get to create some new type of error that expresses that, which can then be recovered from or not. And as you go up the stack, the next level up, you get to say, okay, so the user account create failed. Now I know how to turn that error into an HTTP error, right? To say, oh, well, that's going to be some sort of HTTP status code and do that kind of thing. And you basically get explicit handling rather than just like, I guess we'll try catch it and then we'll send a 500. So to me, the primary benefit comes when you're kind of in more mature software, where you're like, okay, we need to start handling all the cases a little bit better so we can provide a better experience. Sometimes even to the developers trying to debug the problems, but ultimately to the user.
I'm really new to TypeScript. Actually, that's why I came, just to kind of understand it a bit. Our team is thinking about using it. The only one who understands it is my boss. So, the task, is that something that's unique to TypeScript, or is that?
So the task is a library. So like basically task is it's like a new take on promise that doesn't really aim to replace promise, just aims to add a new step in front of it or behind it, I guess you could say. So it's just a library, and this is in any case, the biggest drawbacks is like this isn't some built-in thing, because if you're in a functional language, something like this would actually be more built-in. So this is just something you would npm install as far as like, and more ideally, like I said, on your server stack, right? If you're running Node on the server, if you're running browser, I do personally use it, but it mainly just lives in like AJAX requests. Like all my fetch logic is handled in tasks, and it lets me do some pretty cool things. But yeah, I would basically say that this is something that just leverages TypeScript. It's a library, and it really will help you out more if you're on the server side.
I think our challenge so far has just been handling types for events, because we have a lot of customer events through Solar, and it says detail doesn't exist on the event options. You go, but it does. So trying to declare all the types and do all that, it was just out of scope for us.
Right.
So
Yeah, I mean when you take TypeScript into your existing application, TypeScript has been a personal journey for me that I dove into maybe 2 years ago, and I found that it changed a lot of the way I think about writing code, and overall it's basically taken me from being this like, sorry to any Ruby programmers, but what I assume is like Ruby programmers where everything is dynamic and can be meta-programmed, right? I did that basically to start. I was just like, this is amazing. I can make anything, and I can then generate the thing that makes the thing. But I've really grown to appreciate life on the more explicit side with TypeScript, because when I can leverage TypeScript as a tool, and when I can basically so a lot of people knock on TypeScript because they're like, well, it doesn't test my business logic. What I've come to do, and I'm maybe a little bit on the deep end here, but I've come to attempt to codify my business logic as types so that I can use TypeScript to help me. And when you just introduce it into a company, some kind of event systems are actually a really interesting place where you might use what's called like a discriminated union pattern. And if you don't know that, and you don't know how to use that, and you didn't do that to begin with, it might be really hard to type it. So you can end up with that problem where like the cost of onboarding TypeScript is like rethinking the way you do your code.
I saw, maybe it was in the Meetup, but I saw something the other day that said converting to TypeScript helps somebody reduce errors in their code base by like 30%.
Yeah, TypeScript is pretty good at catching like common programmer issues. Linters can do similar things, but when you have TypeScript, it's really about creating contracts. And so when you write a function, you are contracting to somebody that says, these are the inputs to this function, this is the output of this function. And TypeScript is going to enforce that function. So whether it's you 6 months from now, like looking back at code that you've written, or some other developer that you don't like very well, you know that those types are going to be returned because TypeScript says so. So that's one of the biggest benefits. And typically when people ask like, oh, why should I adopt TypeScript? I typically write, some mock function that has a comment that says 500 lines up here, 500 lines down here, and then math random statement in the middle that has just a raw return. And that happens so much where you get like this JavaScript function, and somebody identified an error state in that function, and then just said, well, if this error state is, I'm just going to return. Whereas your expectations are different than just like undefined. So those things typically, with TypeScript get caught right away, because you say, this is always going to return a string, for instance. Versus if you don't have TypeScript, it's very easy to forget to test that raw return, that TypeScript never stops you from building anything, but it will throw fits like crazy. So, I mean, if you're just testing, that's the benefit. Yeah, you don't have to have it perfect, but eventually you want to get to that place where yeah, it's compiling. You probably want to feel like your builds, at least your CI. If it's not really. Yeah, someday we'll have another intro to TypeScript class for Meetup or whatever.
Yeah, I was talking about it earlier when on the TypeScript documentation it says 5-minute intro, like this is all you need. I'm like, I was fine until I got into calling events and stuff. It's like, it worked too long.
Yeah, you get introduced to TypeScript, but then you have to apply it. And
Yeah.
that's what it's good.
Thank you.
Yeah. Any other questions?
I kind of have a question. I'm not super TypeScript outside of using it in React, for example, and you know that here a while back from promises into observables and leveraging RxJS. So I kind of just wanted to hear like how that would compare this. I mean, like obviously this is you mentioned this is more for your server side. But as far as like observables and RxJS, how that compares to like this or similar, what are your thoughts on that?
Yeah, I was sort of thinking about that just over the last day because I started to realize there are a lot of RxJS API similarities. Like I think the feel of the pipeline is an RxJS API style, if you will. I think they're fundamentally different, and basically RxJS is the idea is that you have a set, you have a collection, you have some collection-like thing that happens over time, right? And so you can think of that as API calls over time, browser events, and that sort of thing. We're just, synchronous sets of things as well. And so really it's, I mean, like it is in the name, the emphasis is on streams. And here, the emphasis is more on I guess you could say pipelines, but it's creating a data processing pipeline, and so it's really going to happen like based on some input. Events kind of happen based on the user input, so I suppose what I'm saying is I think there's possibilities because I know that the way I would probably first thing would be to look at how RxJS maps promises to observables, and then I would look at how I could map tasks to observables because I think there's a pretty strong analog there. And then I know that like with RxJS, you can actually, you have your I'm actually forgetting the names of the callbacks, but basically you get 3 callbacks, right? You get like a value callback, a done callback, and an error callback. And that kind of feels really analogous to me to like, okay, well, we have explicit success and failure. So I think there's room to integrate this into the RxJS ecosystem in some way, but I think that this is a little bit less geared towards events and more just geared towards like gritty processing. At least that's how I see it. So I think maybe not as much integrating into RxJS. I'm myself just learning it a little bit. I use it on the front end. It's possible to use it in a lot of cool ways on the back end as well, and that's where I think I would play with it and see like what kind of maybe some new light bulb will go off. But since I haven't tried it, I'm going to say maybe not as much opportunity there. Cool.
Well, thanks, Alex. This new thing that we're doing, Type This Way, which is going to be a chance for us to take JavaScript functions or common JavaScript functions and patterns and convert them to TypeScript. And so since this is the first time trying this out, it might be a little bit bumpy. So if everybody will let me know how they think about it, that would be great. So the idea is we have 3 functions or 3 scenarios written in JavaScript, and it will come up on the TV any minute now. Nope, nope, because I'm not plugged in. Cool. So essentially, we have 3 scenarios written in JavaScript, and we want to kind of have people come up and type them so they're written in TypeScript or converted to TypeScript. And so anybody brave enough to kind of come up and do that, we're going to go ahead and give a copy of Milestone Mayhem. And if nobody is brave enough, then what we'll do is we'll just do it all together. So the first scenario we have set up here is the random. So what we have is a random function, and based on the type that we're putting in here, we're going to go ahead and return either a string or an integer or a float, right? And so what we want to do is we want to have these actually come up with the type that's going to be returned. So in the case of on line 14, where we have car, we should get a string type for this letter here instead of all of the possible return types. So TypeScript does a pretty good job of identifying return types and then providing them to us. And it's going to throw a fit unless I do this.
Or you could always just do the default explode.
Default what?
Explode in the default case.
Oh, throw?
Yeah.
This is more fun. So TypeScript's going to throw a little bit of a fit here because I have all of my strict options on. And so what we want to do is whenever we get a car, we want this type here to be of type string. And whenever we get integer or float, we want this to be a number or a real. And whenever it doesn't equal any of those, we want it to be undefined. So why don't I leave this up here on the screen for a little bit, and then if somebody wants to come up and write types for this, we can do that. Otherwise, we can write types as a group. Oh, no, see, Alex volunteered.
Bump the font up.
What's up?
Can you bump the font?
Oh,
Towards
yes. How's that look?
Much better.
Yeah, that's a lot better. So we have somebody want to come up and take a try at this, or right now I'm on TypeScript Playground.
Give it a try.
All right, Sal. So I'll talk while you type. How's that?
Mm-hmm.
So one of the requests we kind of got from people that showed up to the meetup is, hey, we kind of want to see like common scenarios, and how do we actually like make these scenarios, into types, or how do we type like certain scenarios? And so like having a function that returns different cases is a pretty common a setup. So hey, you have a string, and so you have to actually kind of get back a subset of data. So what Sal's doing right now is he's just going to create a function definition for each. So with TypeScript, you can override all of your, you can override all of the types and provide different kind of function declarations or definitions, and then explicitly state what they return. And then your last one always has to be wide enough to accommodate all three of those up above. So your actual implementation right there.
I've never known that the actual function.
Yeah.
I always just untype it because I can never figure out how to make it work.
How to union them together? Yeah.
Oh, this is helping already. I like this.
Is this what you were expecting?
Pretty much, yeah. So another approach.
So do you not need to put in the type for the actual function?
We
Or
can.
the return type, sorry.
I mean, I guess we can do string or number.
Yeah,
It
or
doesn't-
undefined.
Yeah, right. Number. Throw.
Yeah, you have to throw them.
Yeah.
Sure. Why not throw big ints, right? Like a React developer might.
Throw in the process of error.
Cool. And so what we get is when we, hey, disappear. So when we hover over it, we can see that when we put in when we put in car as our parameter, we get back a string, and then we'll get back a number for the other two. And so if we were to put in something else, first of all, it won't let us, and then because we haven't actually, well, actually, it should let us, shouldn't it?
If you made a.
Oh, you made it never.
Yeah, if you duplicated that, whatever, line 5 as type string return never, as another overload,
Oh, okay.
right?
Yeah, that should work.
I don't know if we're gonna try it.
Yeah, so it's
We need one more overload that's the sort of catch-all. We need to return never. We need type a string.
so typically when you write these, you want them to start out narrow and get wider as it goes down. Okay, so it'll work. So it'll return a never, but you know that that's going to throw when it gets there. And you can't do anything with a never type. It's just there as something that's definitely going to throw.
Yeah, in practice, I wouldn't do that. I would leave it to the 3 explicit types and then let TypeScript handle
Yeah.
it.
Yep. Another approach is you could always make this generic, and then you could put those 3 types there, and then have a conditional generic on the return type, which is a lot more complex, but
I was wondering why you said explicitly that it was TypeScript 9 or 2.9 or whatever, because it would have conditional generics.
wait, where's TypeScript 2.9?
I thought you said that
Oh.
in the beginning. That
No, 2.8 has conditional generics actually, but so you could use a conditional generic. The only time you might prefer a conditional generic is if you want to use it over and over again, and so you declare that generic type and then use it over and over again.
you want me to show the generic type?
Yeah, why not?
This may not go well.
Even better.
It's considerably trickier. Right? Something. I'm winging this. I'm not sure if this is going to end right. Okay. Nope. Already not right.
Yeah, so random needs to be, yeah, right.
I'm going to make t extend. So we're going to pass a generic parameter of t, where t can be either char, integer, or float, and then our argument will be of type t. Here we're going to say something to the effect of where t extends char, then return
Ooh,
string. No?
Could you create yeah, that's right, but could you create a type up above rather than writing a long paragraph right there?
He's doing it to production company.
T return of t, or some
Yeah.
better name than that.
Yeah, better name than that, so that's
type
fine.
T
for now.
return
This is actually live.
what is
does it go? Goes
Uh,
there or on
T,
the other
yep.
side? Okay.
Yeah.
Extends. I'll copy it later.
Oh, do you have to duplicate it when you do it that way?
I think so. Well, I guess I wouldn't have to necessarily, but it would make it a little bit more exhaustive.
You could declare a type up. You never
Yeah.
have to duplicate. You could
Right,
declare the
right.
type up above.
Type char and return string. Otherwise, if t extends integer, then return number. Otherwise, if t extends, what the other one? Float.
Float. Now you can use your or block at the integer.
Union integer.
Can I do that? I guess you're right. Yeah, I was thinking about how to do it, but you're right. It is just a union. Or float. Then where's my parentheses? Then number. Otherwise, number.
Seems way overcomplicated.
It is.
If you're going to reuse that T return, it's useful.
Why is it pissed off?
Or if you're like Lodash or whatever, Lambda or something like that, who knows, something like that where it's useful.
If you're using Lodash, you're used to complexity
String
anyway, right?
assignable.
Yeah, I just mean within your library, it's nice to provide this to your consumer.
It's not super happy. Can you see why?
What's the error?
Hold on 1 second. It's that I don't know, close everybody. Hang on, that's him.
Do you need to nest parentheses?
No, but I was afraid of otherwise. But it's saying string's not assignable to t return. But I discriminated it there. Type is char integer or float. It's not right?
Oh, this is one of the limitations of TypeScript. So I'm glad you did this. You're going to want to put at the end of that on line 12
Okay.
as
As what?
T return
Yeah.
T.
Is it going to discriminate properly?
Yeah.
What if I said, it's not this, right?
No,
No,
I don't think
that's
so.
not the problem.
I'm pretty sure it's this.
That's very different than saying as any, right? Where you're just saying, ignore it. Like it's still
It's still
checking.
explicit. I would assume so. I mean,
Now hover over,
Yeah.
would you hover over 21 first? Make sure that we
Yeah.
get the right types back out. Yeah. So the right types coming back out. So as any would work, but it's a little bit broader and it won't catch if you do something wrong.
Right. Yeah.
Yeah.
That's what I'm saying. Big, like, because it feels like you're
No.
doing the as
Flout.
any. But you're not.
it's not catching. It's not narrowing. You dig?
Oh no, okay, so that T is going to be of all types.
Sure. So we should make this t a float.
Yeah, if you were to put T as a float, it would expect you to return that, but it's not gonna check your case statements. It will never check your case statements because you're allowed to do that. You're allowed to put in different cases, like add a case statement that's anything.
Mm-hmm.
It will allow you to put in whatever you want. Your types are checked at line 9, but your types are not checked in your case statement or your switch statement.
You don't think there's any way to do it
There-
without this as return?
No, because there's no switch is not a generic. You know, if you look at it like that, switch isn't bound by the type.
No, but if we said console.log type here. Yeah, type is not that sucks.
Yeah, so switch is never bound by your type because you can define dead paths, right?
Mm-hmm.
I would be amazed if you got this, but I'm not going to stop you because this is
Still not discriminating. I'm trying
Right.
to discriminate t to just be char inside of this case, as it was before when
I think
Oh.
you need the default case where you expect never.
try making a type guard. So case.
Yeah.
Oof. You would need a type guard, I guess. And then you would change your switch to if then else with type guards.
Yeah. Yeah. You would have thought, Alex?
Yeah, the expect never trick.
trick, but it's a thing that exists on blog posts. So we'll call it.
I read it somewhere. Hey,
so
Sal, you want one?
So many of them.
Oh.
I love them.
Okay.
the idea is we would make
Fair enough.
a function that says expect never, and it's going to take some value, which is going to be of type never, and will return never. And in here we just throw new error. Nope. This keyboard is interestingly different. So
Welcome to Windows.
no, it's not that part. It's just feel. So here we're going to take. Everyone else is using type, I think. Alright, so what is my shortcut?
What are you looking for? Oh, look, you have actual end and page up, page down piece. Isn't that amazing?
Go away, and then we'll just use what's. Is there not like a hold it down and it keeps going? Alright, so in here we'll just expect never with type.
Okay.
And so the trade-off would be we can't allow anything but our union of literals. So
So if you mouse over type in that line 18, did we discriminate the union? 18. So we're there.
well, this is so I think what would be different is you wouldn't accept a generic.
You're just making T that.
Exactly. So
Yeah.
come on.
How they're all underlined in red.
He really hates me.
Just angry.
This, and then becomes that, and then I don't know what it's going to return, to be honest.
Right, that was the tricky part without the overloads.
So this, I guess this is our last hurrah. There's no tea or spoon. But what I know is in here we've constrained the type. So now it's not char, integer, or float like it is up here. Instead, it becomes like it's known what it is. Can we move it down? Cool. And then here it knows it's integer. And so I'm sure there's something you can do with that, but that's some new
That's
step.
nice. You don't have to use type guards in order for that to work.
But if you mouse over letter, you're still going to get the weird union of string and number. On 27?
Oh, yes. I haven't figured out how to get the return to map that bit, but as far as getting to not do the as return, I think that would help. So maybe if you did t return and you just made it when it extends this thing. Oh well, I guess you still need the generic. Gosh darn it! All right, let's stop.
So, yeah, like a simple return function can really get messy, and it really depends on how exact you need it. Like what Sal started off doing with having multiple function definitions on top of it is probably what most people want to do. Like most of the time, unless you need to define a generic type that's going to be used throughout your application in more than a couple places, where, then we decided to go with the t-return type, that's kind of where you want to go. You kind of want to start with, oh, that might be, oh, okay, good.
Adios.
Let's see. So there's various levels of like, well, how well defined do you need your system, and how well genericized do you need it for reuse? And so those are always considerations. I don't know. I think this is probably a great place to stop. We have other ones, and we'll just save them for the next time. But thank you everybody for coming, and hope to see you next time.